Motion control is a challenging subject as it both requires computational power and real-time control of I/O. Traditionally, this has either meant going with a microcontroller-based system like a GRBL controller or a Marlin-based printer that uses the microcontroller for everything, being relatively limited on resources, or going with a computer like MASSO uses and then having problems with real-time I/O like step pulse generation on time, as modern operating systems are just not really made for sub-millisecond accurate I/O stuff. There's always background tasks and things like that. Klipper solves this issue in an interesting way, as opposed to just scaling up the real-time microcontroller's power, like for example something like a MASSO controller would do by adding an FPGA. It instead splits the architecture up into the microcontroller that just does the real-time I/O stuff, and a normal computer, usually a single board computer like a Raspberry, that handles all the complex computation. This genius separation into two parts allows Klipper to both generate very high step rates, as well as having pretty complex path generation, like avoiding resonant frequencies, as well as having all the power left over to host a web interface for control and many other things. The link between the two is the Klipper MCU protocol, a binary encoded serial protocol that allows the host to send the microcontroller information about when to make which steps for the microcontroller to then execute. The host starts by synchronizing its clocks to the internal microcontroller clock and then sending package saying exactly on what clock cycle the microcontroller should, for example, generate a step output. This allows the microcontroller to run very fast with very little overhead while all the computation is done on the main host. This synchronization also allows multiple microcontrollers to be connected to the same host, easily extending the number of access or inputs and outputs the controller can have without developing additional hardware. This also allows Klipper to use many existing boards, like most printer main boards and several single board computers like Raspberry Pis. This approach is quite interesting for developing mechatronics applications, as it simply allows real-time control with very little effort.